Hello and welcome to our webinar, Experience-Based Selection of Software Development Measures and Methods which are required by ISO 26262 with Martin Heininger. My name is Polina Handziska. I am working in international sales and marketing at Verifysoft Technology GmbH, and I have here also my colleague Roland, who is technical consultant in our company and who will be doing a tool presentation at the end. So I will give you a short insight into our company. Verifysoft was founded in 2003 as a distributor for Testwell tools in Offenburg in Germany. It is near French border. And since 2013, we are owner of Testwell tools, in particular Testwell CTC++ code coverage analyzer, which we purchased from the company Testwell in Finland. We have also we are also doing distribution and support of some complementary tools, Grammatech, CodeSonar, and Imagix 4D. And we are organizing seminars, for example, test of embedded software, also with Martin Heininger, who will be the main person during the webinar today, our speaker. So we have more than 700 customers all around the world in 41 countries and on all continents. And mainly our customers are from safety critical areas like healthcare, aerospace, automotive. Our main tool is Testwell CTC++ code coverage analyzer, which is working up to the highest levels, MCDC coverage level and MCC level, which is also required by the standards. And it works with all compilers and all embedded targets. And so whatever you have, the tool should work. We also have a qualification kit available for the tool for the main safety standards. And regarding the complementary tools, which we also provide, for example, Imagix 4D, it is a tool when you have, for example, legacy code and you want to understand this code, it is the best tool for you. It is also doing some reverse engineering, architecture visualization. And basically that was it. We wish you a successful webinar, and I am now switching off to Martin for the next step.
Before we start with the topic, practice-based selection of ISO 26262 methods and measures in the software development according to 26262, let me do a short introduction of myself. My name is Martin Heininger. I studied electrical engineering decades ago. Since 2018, I'm managing director of HEICON Global Engineering, a consulting company focusing exactly on the topics we are discussing in this webinar, actually experience-based professional development or using of methods and measures in software development processes. I have a strong background in aerospace, about 20 years experience in aerospace, and that's very valuable as the aerospace industry is the industry with the most of the experience of all these topics we are discussing nowadays in automotive, railway, industrial, or other industries. The aerospace, the standards, the 26262 in the automotive and the DO 178 in the aerospace, the text in the standard is not so much different anymore. It's very similar. The difference nowadays is in the experience of how to interpret what is written there, and that's just the strength of HEICON. We're doing hands-on coaching with the focus on requirement engineering, test engineering, and the management of the functional safety. Yeah, and that's it. Let us go into the webinar. I have split the topic into these smaller parts. First of all, I want to focus on these terms in the standard, in the 26262, informal methods or principles or notations, semi-formal notations, and formal notations, because especially the 26262 is quite, these terms are quite extensively used in all the software development methods. And yeah, there is a lot of confusion out there in the practical world. And I want to bring in some thoughts how we can handle it properly and in a way that even external assessments actually are successful. The second topic is software architecture, safety architecture principles, and actually requirement engineering, both together. The third topic is then coding guidelines. Handling of code, I have called it handling of coding guidelines, and you will see when we go through the tables, there is quite a mixture where there are coding guidelines, let's say hidden in the standard, or how you have to organize or can organize your processes if you do it properly. And at this point, you will see that it's not actually the best idea to start in the 26262 and go through part 6 software chapter by chapter, do the work products like they are defined in the standard, handle the tables like they are defined table by table. This is quite extensive then, and duplication of work, and in the end confusion and less traceability and less understandability of the system, or of how you have done it or what you have done. So this is the coding guidelines is a good example for that. The next topic, review static analysis, is coupled actually somehow to the coding guidelines. Static analysis is more than only code review, or only more than review. Yeah, it's by tool support, getting information about missing coding rules, runtime errors, and other things nowadays we can do with static analysis. Let us have a look in that and what the standard requires from us actually when we want to fulfill the 26262. Unit integration and system test, the big topic in the end together. Because of the limited time in this webinar, I put this huge topic actually together and take out some highlights on it. But of course, this could be even a separate webinar, or maybe we handle it afterwards in the question and answers section. And last but not least, a take-home message. So before we go into the 26262, let us have an understanding on some terms, like I use them. It's now already an experience-based driven conclusion actually. And we have here the typical V model, implementation on the left side, verification on the right side. So far, so good. What is maybe a bit specialized is I heavily separate between requirements, textual requirements describing the functionality, and architecture and design, where I have not spent now another level. Architecture, which is the graphical representation of my system, the graphical system. And that's very important. And I can have actually more than one level of requirements. The same in the architectural design. These are typically two levels. Then on the other side, on the verification side, due to this webinar now, or even in general, we have two things. We have dynamic testing and we have static analysis, and I put this together on everything under review. Yeah, sometimes tool supported reviews, but it's all static. So I have the source code, the documentation in front of me, and I'm going through it and checking it through certain points. And dynamic testing means I execute my software. I compile it and I execute it on a target. I execute it on the PC, and see whether the execution delivers the results I want to have. So these are the basic distinctions I'm doing. And now we're coming to the first topic, semi-formal, informal, formal, because we can ask this question for all of these. Yeah, semi-formal requirements, semi-formal requirements, informal requirements. The same for architecture, formal architecture, semi-formal architecture, informal architecture. Even for review and for dynamic testing, we can ask this question, and it is actually in 26262 there. Formal verification, semi-formal verification. We will see this in a few seconds. And for me, it's important to separate here in between these topics. Otherwise, you don't get proper answers. And that's the level of this webinar here, to go through these topics and provide topic by topic answers and not generic statements, yeah, which sometimes happens. Yeah, everything has to be formal. That's the only way to go, or there is no what is semi-formal. Let us go through these topics step by step and see what we get out of it. First of all, let us go into the definition of the 26262 part 1. So the very first one there, they define actually informal, semi-formal and formal notation, and semi-formal verification and formal verification. And here you see informal notation is a description technique that does not have its syntax completely defined. Okay, this makes sense when we put it together with the second one, the semi-formal notation, description technique whose syntax is completely defined, but whose semantics definitions can be incomplete. And the formal notation is a description technique that has both its syntax and semantics completely defined. Semi-formal is the syntax completely defined. You have graphical, you do model-based development, and you have a clear definition of each element in this model, about its meaning and what's going to happen. This means the syntax is completely defined, is fully there. The semantics, what the system is doing more or less, is obviously not there or is incomplete. This is the challenge, is the complete semantics of a system, to describe by mathematical, so unique definition. This means formal, formal definition, complete a full semantic system. And in informal notations, we take, if we use the architecture example, we take just some block diagrams with input and output errors, but we do not exactly define what the meaning of it. Like in UML this is done, but if I take normal block diagrams and just draw an error, then I don't see, I don't have the exact definition. So this is, first of all, the separation according to the 26262. The verification, the semi-formal and the formal verification. Please note there is no informal verification defined even. A verification that is based on a description given in a semi-formal notation. So this is kind of automatic. Once we have, so we can have only a semi-formal verification if we have a semi-formal notation. So definition of requirements, definition of architecture, design has to be semi-formal defined. Then we can do then we do actually semi-formal verification according to the 26262. And the formal verification method used to prove the correctness of an item or element against the specification of its function or properties in formal notation. For the moment, take it, I think you can imagine already this is quite a big challenge, yeah, to achieve that. Second part or next step actually, requirements architecture. So separation. And why do we do this separation? We have on the left side, or I have drawn on the left side the what, and on the right side the how. And the what is the requirement documentation in a system. So what is the system doing? Why is the customer buying the system? What problem is solved? And the description of this problem solution, yeah, the customer problem solution, that's the what, and that's the requirements you're going to document, or you should document. And where the best mechanism and the almost only mechanism so far is natural language. How to describe what a system is doing, as the best method is natural language. And consequently, or experience-driven, the last 20 years, we know that it's the best way to document this in a database text, which is defined in a database in individual requirements as you know it. And on the other side, the right side, the how. So I have a system, this is doing certain functionality, measuring of certain signals and taking consequences if the signals are out of boundary or whatever, stopping driving the car or whatever. But how it is built, what hardware is there, or what parts are implemented in hardware, what parts are implemented in software. So how it is done. Data flows, control flows, state diagrams, activity diagrams, sequence diagrams. These are all heavily driven by the how, yeah, how a system is built. And this is much better, or the best way to document this is graphic, yeah. So the architecture of a system is the main part of it. To describe in diagrams is a great idea, or is the idea, yeah. It's really awful if you document this or try to describe this all in text, yeah. So typically this is graphical tools, yeah, graphics, different tooling there available on the market. Of course, this world is not black and white. To also say this, to state that, yeah, there is something in between. For example, architectural constraints are why you're using this architecture is sometimes actually is also very important. And this is definitely also text, but it belongs to the architecture, for example. And on the other side, the what, the requirements, there are scenarios where it is worthwhile to add a diagram actually in the requirements to make the text more understandable or more easy. And the wonderful or perfect example almost for this gray area actually are the states. If you have a state machine on system level, like a television, yeah, saying, okay, it's in standby, it's switched on, switched off. These are 3 states and there are certain things happening. There definitely a diagram is, even in the description of the what, makes very much sense actually. But for our webinar here, it's important to have a separation, to not state the requirements and architecture is all the same. Yeah, if you do that, if you say it's all the same, you will struggle with the interpretation of the 26262 from my perspective. Therefore, I'm putting this here. So going into 26262 now, I have first of all selected specification of requirements. Yeah, and for me, this is the weakest point of the 26262. They put this outside the software part, because software part is part 6, and we have here part 8. In the part 8 is supporting processes. In the table 1, there is defined there are the methods defined to specify the safety requirements, and there we are here with informal notation of requirement specification, semi-formal notation, and formal notations. And you see here, for all of you who have not seen this before, there are different ASIL levels, and the standard makes suggestions how strongly he recommends it. Yeah, the plus is highly recommended, the plus is recommended, and a circle would be neutral. So you can see in the lower ASIL levels, informal notation is highly recommended, and it's not highly recommended on the higher ASIL levels. Instead, that's how to interpret these tables. Yeah, you need to You need to select the right number and the suitable methods for your implementation. And as you can see already here, this depends on the ASIL level, of course. Yeah, on a higher level, ASIL C, ASIL D, the standard says prefers actually the semi-formal notation for requirement specification. And the formal notation is kind of neutral. It's for all ASIL levels, just as a recommended. And what does this mean now? Many people are sitting in front of such tables when they start first time in a automotive project. So what to do, especially if you have a project like ASIL C. So typically, so what to do? What means semi-formal notation for requirement specification? Yeah, because that's what the standard recommends for ASIL C. So my practical experience here is, yeah, informal notation is a textual description of the software without any detailed constraints. So there's just text, maybe separate blocks of text. So not every not one page. Yeah, it's several elements, several sentences put together, but it's just more or less text form. This is for me an informal notation of a textual requirement. As we said here, specification of safety requirement means actual textual requirements. So we're not talking about the architecture. This will be in a second. So the semi-formal notation is, from my experience, and this works very well with assessments, yeah, textual description using requirement templates like ERS, easy approach to requirement syntax. Here you have the link to it from Alistair Mavin. This is semi-formal notation of textual requirements. Yeah, this is well accepted, but not at all mentioned in the standard at all. And formal specification of functional requirements is not existing due to my experience. So far, no use in industrialized project realized. Yeah. And I will come to this in a second. What is there due to my knowledge actually on formal notations. However, please note that even the DO, the 26262 actually puts the formal notation only with a plus with recommendation and not with highly recommendation. Theoretically, formal notation would be the very best and would solve a lot of problems. And therefore, they would need to say, at least for ASIL C and D, they highly recommend. For me, this is a sign that you can see we have not the methods there, yeah, for industrialized projects, yeah, industrial sized project actually to use formal notations. This is still under research and under development. And that's what you can see here in this line. So we are focusing in typically on semi-formal notations by proper requirement engineering. And that's now just to give you an idea about it, nothing more. If you want to know more about this, then come to my requirement seminars or other webinars where we talk about requirement engineering. But this is a table actually of the easy approach to requirement syntax, where you have templates, textual templates. Yeah, for example, behavior-driven, wanted behavior. If a condition, define a condition, then the system, active sentence, shall do something. And that's also when and while and where you can specify, and you get then one sentence where one active sentence with a clear condition and a clear action, the system responds. And that's the idea, and that's the goodness of the easy approach to requirement syntax. And actually, there is a key word there, shall in English. Each requirement should have a keyword, and it's typically the shall. So, and this is accepted to be semi-formal requirement engineering. Further statements of practical experience here, semi-formal requirements. If we do not accept methods like ERS as semi-formal notations for functional requirements, we would have an issue in the ASIL C and ASIL D projects fulfilling the ISO 26262. Because then we have no textual requirements. Yeah, the best we can do is exactly these semi-formal requirements. However, the general weakness overall on the 26262 is the treatment of textual requirements. Yeah, To some extent, from my feeling, from my experience, the authors seem to think that there is a better alternative, but due to my experience, but it's not. Yeah, they think there's a better alternative to requirements, but I think that's not actually. To describe the functional black box behavioral system, more or less the only measure we have in the industry overall is textual requirements. But the 26262 does put this quite to the side, more or less, but still accepts it actually. Yeah, due to this first sentence here, there's no issue. There's each project, there are textual requirements, and the best way you can do it is using requirement templates. So looking into the theory in the formal notation, I have here 2 links to the University of Saarland and University of Bielefeld in Germany. You can download here these PDFs where you can have an insight on the definition of the specification language set, which is quite old actually, and the specification language TLA+. And actually there are others like ASM, CAFE, VDM, RISE, but they are, due to my experience, used or promoted in the university environment, but not really used in the industry. And if you go into take a look into it, you will see the limits. Yeah, it is very, very hard to describe in a formal way and a mathematical way functionalities. Yeah, the what. It's more easy to describe the how, but we are focusing here on the what. Yeah, the table is about the what. We're discussing the requirements. And you see now again, it's a good idea to separate between requirements and architecture. Now let us come to the architecture. Here we have the same, and that's actually this is the confusion of many people. Again, they're talking all about the same things. Yeah, but the headline is different. Yeah, and I put here together 2 tables which have exactly the same content, and that's how we are going to do it in the 26262 or in any of the functional safety standards. We have a strategy. Yeah, when we're starting with a project, and we are combining tables and combining our arguments. Yeah, in a safety plan actually. That's the most effective way, and we're not following blindly just table by table and implementing what the table asks us to do. We put our own strategy there. So software architecture design and software unit design is the same table, and you see there methods can be natural language, so describe the architecture in natural language. I just said before it's not a good idea, but the standard still allows it. And then further methods can be informal notation, semi-formal notations, and formal notations. And related to the architecture, for me, informal notations are just diagrams drawn without a detailed syntax definition or with no syntax definition. Yeah. Semi-formal notations, diagrams using a predefined set of definitions like UML. Yeah. Or tools where you can generate a source code from. This is maybe not fully UML, but MATLAB Simulink and Skate, where you can design systems. Yeah, if you can generate source code from it, then the syntax has to be completed. Yeah, so this is also a sign that you have definitely a semi-formal notation. And again, the formal notation is actually not so easy. To some extent, we could argue that models from which source code can be generated are satisfying the definition of formal notations. However, from a theoretical point of view, even this unit design models may not fulfill the definition. And again, you see formal notations only on the plus. Yeah, due to the plus of the method for all ASIL levels, this is discussion which does not play an important role in the practice. Yeah. So we are focusing actually on semi-formal notations so far, and the rest is university level. And also, what I want to highlight here, there is no strong separation, not even the standard, because the same table here, between architecture design and unit design. Therefore, you should use this for your design actually, and put the architecture and the design in one document, and just make it, the design is a bit more detailed than the architecture, and you have a data flow or a flow of information from the architecture to the detailed design. So you're going more and more into the details from architecture to the design, and the goal is to achieve a traceability into the source code. So you can stop with your detailed design or with your design once you have a suitable traceability into a source code. So a few hundred lines of code represented by a box, maybe 100, a few hundred is a lot, depends on what kind of source code it is and what kind of functionality, but can be really even 100 or more than 100 lines of source code. This is a good idea. And that's what even is promoted more or less by the standard, yeah, as he makes not so much difference between these two. Further, now the unit verification, the semi-formal verification and formal verification in the table in the part 6 now in the software table 7. You see here again, formal verification is ASIL A and B not even recommended, yeah, and only recommended on ASIL C and D, and semi-formal is preferred, yeah. And this is due to my interpretation and experience, actually, requirement-based testing, model-based testing, reviews performed by inspections, all that is fully fulfilling semi-formal criteria, and is fully accepted, actually. And again, the formal verification does not play really a role. So that was the first huge topic, yeah, and key topic, I would say. Let us go now a bit quicker, not so deep, maybe into this topic, safety architecture and safety principles. Safety, again, as I mentioned here, a table actually, and I didn't mention so far in this webinar, going through these methods and measures of the 26262 is meaning focusing on the tables, because the tables in the standard, in the software standard, the part 6, yeah, the software part, go through all the topics of the development, yeah, and therefore we are focusing in here on the tables of the standard and a little bit ignoring all the text which is there, yeah. But for the selection of the measures, this is good enough, and that's the way to do it. Yeah, it's not. I'm not saying you have not to read the rest of the standard as well. This is not the statement. So, but now principles for software architectural design. There is a lot of aspects here there, and you see most of them are highly recommended, almost independent of the standard of the level, except maybe ASIL A. It's a bit less. But these are just normal ways. And my statement here is the model-based development does support these documentation of these aspects very much nowadays. Yeah, and having a MATLAB Simulink model or a SCADE model or any other model, this helps a lot to document this. This was in former times, if you have handwritten source code, it's always a discussion. How much do I need to document? And there's so much work to do it, but it's really worthwhile, yeah, for the verification, for the understandability of the system, for questions of the certification or the assessments. Actually, you should have a proper documentation of your architecture, showing, for example, hierarchical structure of the software components. You should have a scheduling diagram. You should have a documentation of what is about how you're using interrupts. Yeah, it's just written restricted use, but what is your concept, how you're doing it, and for the others as well. Here, my recommendation, all these points are actually is a graphical software breakdown, not in text, it's mainly in graphics. Here is the graphical timing behavior. And these aspects, actually, the last one, appropriate management of shared resources, actually is a key point for the later on coming data and control flow analysis. Another table of the unit design here, you see quickly, or my recommendation is these aspects here, which I have mentioned here on the left side. They are documented not in the architecture, or in the design, they are more documented in the coding rule. Yeah, this is a tool-based coding rule. The tool-based means automatically, you can check it automatically, yeah, for these ones. And for the remaining ones, these are more part of a checklist. Yeah, so you you do it's an architectural constraint. If you do it perfectly, yeah, you say I'm not using pointers, for example, or restrict my usage of pointer. And what is your restriction? This idea, this principle is then checked by a review. And things like no hidden data on control flow, it's very, very difficult actually. What is hidden exactly? Yeah, that means it's not obvious from the architecture. It's some things happening which are not clearly intended. Yeah, for example, something like that. So these are the architectural principles, and I would like to summarize here. You see, in the first table was graphical documentation. Here I said this table here is documented or concluded actually in coding rules, and we will come actually coding guidelines will be the next point. You see here that we have already a mixture here. Yeah, this is unit implementation and design, but the documentation of it is more or less a coding rule. And if you do it perfectly, you do architectural constraints. Yeah, you define somewhere in your architecture that there's only one entry point and one exit point is allowed for a subprogram. But actually, in my experience, this is not in the architecture defined. This is just a coding rule. Yeah, this is the documentation of such point is done in coding rules, and that's actually good enough. So let us come to the coding rules, because there is another table, and that's actually in the software part, table 1. So the very first one in the 26262 says topics to be covered by modeling and coding guidelines explicitly. Yeah, but you see they have a table there with this headline, and I have just another table found, or I had another table just before of the design, unit design, where I also say these are covered by coding rules. Again, here you see the strategy. You need to implement the proper strategy, otherwise it's not really working. So here, use of language subset, this is typically MISRA rules. This stuff here is in smaller projects really difficult to fulfill. And actually, I have seen several projects where the assessments forces actually use of ambitious graphical representation, but I do not have the complexity to have a semi-formal method there, for example. Yeah, so this is sometimes, yeah, depends on assessments, but for simpler projects, actually discussion points. Fourth topic, and actually highly connected to the coding guidelines, is the review and the static analysis. I thought about putting it even together, but I split it. And splitting it means, again, we are now verification. We are again in the part 8 of the 26262, so the supporting processes. And the table 2 says defines methods for verification of safety requirements. And here again, you see 26262 says the way you're doing the verification, yeah, the method you're using, a walkthrough, inspection, a semi-formal and a formal verification. And looking onto these tables, this is the only way, as my conclusion, or not the conclusion, is just a fact, matter of fact. Yeah, the only way how the verification is done is addressed with the above points. It would be more important for getting better safety results and better documentations in the automotive industry. Actually, it would be more important to establish rules of the content of the verification. Yeah, it is well known nowadays that we can do an inspection formally, whatever it means in details, yeah, but bringing no results. Yeah, having 10 people in a room inspecting a document or any requirements or code or whatever, yeah, but do not really find real problems. It's well proven that you find in walkthroughs even the better or the high likelihood that you find more findings, and all the agile development processes actually goes into this direction. But 26262 in this area here is quite conservative. Yeah. So, and that's what I try to, my approach is to define safe projects or safe systems, or develop methods and processes to have in the end a safe system. And therefore I'm getting here a bit interpreting the standard. Yeah. Inspection second point, the inspection is significantly more effort, but there is a lot of experience required to create valuable results. And HEICON does have this experience, yeah, meaning you're doing a walkthrough, everybody goes and reviews, and you're only making a meeting to fulfill the inspection rules, yeah, a meeting for any open point. All the points which are accepted are not even discussed in a meeting, but they are documented in a protocol or in any tooling that you can see what inspections you have done, for example. Yeah, that's now in very, very short, actually, as the time is running, we're running out of time now. The ISO 262 puts less emphasis on requirement engineering, at least compared to the aerospace standard. Yeah, this is also here one conclusion I had already before, as we have here requirements. Yeah, and this is everything about verifying requirements. There could be much more valuable things in the standard than there should be, from my perspective. Verification of software architecture. Here you see a table of walkthrough of the design, inspection of the design. See, again, it's again about the methods. Yeah, it's again similar to what we have seen with the requirements. So it's the way you're doing it, not the content. Yeah, but then there comes some content things, simulation of dynamic behavior of a design. Prototyping can be a verification of my software architecture. Formal verification, control flow analysis, data flow analysis, scheduling analysis. It's a mixture of measures, and it is, again, you need experience to integrate it properly and to set up a proper set of values. Highlights from my experience is inspection is much more effort, as it's the same as in the requirements. You need to set it up properly. So this means what I said before, you're giving the people a checklist. They are reviewing the architecture, and you take the really experienced guy in your project, guys, only a few with respect to the architecture. They are going to review in a walkthrough style, and then you're putting together the findings and discussing it in an official meeting. That's the most efficient way of fulfilling more or less the whole table here. Yeah, as the formal verification is not existing, control flow, data flow is part of your checklist. Scheduling analysis is part of your checklist, yeah, of verifying is there scheduling defined, and then you're putting it all together in an inspection in the end. Yeah, so that's the way I'm interpreting such a table. I know it's a bit fast now, but I hope you get some idea at least. Yeah. The challenge with respect to control flow and data flow analysis and scheduling analysis, the documentation of the requirement data in the architecture. So it's not doing the review, the verification of it. It is it in the architecture and in the design there? That's the challenge in all the projects I have seen. Yeah, reviewing it is easy. Yeah, but defining it, that's the complicated thing, because there is almost an indefinite number of control and data flows in the software. So this means you need to define the most important ones. So let us come to our last topic. It's a huge topic, unit integration and system tests. And clearly, we can't do everything now into the required details. And you see there are huge tables in the 26262 about software unit verification. Yeah, and if you go and read here, again, we are coming with a standard, comes with a walkthrough, it comes with an inspection, a formal verification. So it's kind of all the same all the time. Yeah. That's the difficulty for starters in this area to get this in the right context, yeah, and to have a clear strategy before you start. And this is this experience-based thingy where I give you at the moment some ideas what this experience means. As a unit verification, there's a lot of things put together. Fault injection testing, as there are dynamic testing, interface testing, requirements-based testing. The last thing is all dynamic testing. This one is here all static, and pair programming is neither of it is pair programming. Yeah, but pair programming is only recommended. You see, it's not really even highly recommended. Yeah, so pair programming alone would definitely not satisfy all that what you have here. For unit verification. So small summary of what my experience here. many people are confused about the amount of measures, and without experience it's difficult to decide about it, what I said. And what I tried to do already also now, important aspects are do a review as a walkthrough and put it into an inspection, the same as also for the units, the same thing here. Do a static analysis, MISRA rules, runtime error checks, by tools, automated, so that you limit your effort of manual reviews. This should be really limited to a bare minimum, and clearly do requirement-based testing, including fault injection. There is only a requirement-based testing actually, because the requirement defines the behavior, and you also want to define the behavior in case of a failure occurs. So from my perspective, fault injection testing is a subset of requirement-based testing, and this makes a table then understandable. So in a first moment or for a first second, if you try to separate these aspects of the table before into these three things: a manual review, automated tool-based review, but still review, and then requirement-based testing, or first of all testing, including putting all together all these test aspects, then you're getting quite a next good step. Now you're seeing I put even together three tables, deriving unit test cases and deriving any test cases. The standard is all the same. And a statement from my side is error guessing. Error guessing should be an important part of the tester's mindset, but it's not really an own method. A precondition for that is a proper safety culture in your project team. This is for the error guessing part here. The rest are clearly things which you learn in a test seminar, but error guessing is something which has to do with a lot with mindset. And functional, these last two are only for the last table here for the full system. And functional dependencies, the analysis of it just goes together with requirement analysis. There is no difference. And I have to stop here because of the running time. And two more small things, software integration verification. I would skip this for this. You can see it on the slides here, how I interpret this this table here, but it's actually the same as the other ones. Having an idea and grouping the methods and selecting the proper ones for you. For the last statement, I would want to make a statement about the code coverage. As the 26262 is the only functional safety standards I know which have two levels of measuring code coverage, and you have it first on unit level, the well-known statement, branch and MCDC coverage, and he has it also on architectural level, the functional coverage and the call coverage he wants to see, at least for the higher ASIL levels. And that's what I want to just make you aware of, because most of the people ignore this one here, the functional and call coverage, and there are some technical limitations. Therefore, there are good arguments to ignore it and to do only on unit level the coverage. But from a safety perspective, it would make a lot of sense to measure and prove this. And this is, from my perspective, the future, to do here on integration level coverage measurement. And this will be only suitable in a proper way if you do if in future the new technology of non-intrusive code coverage measurement comes up and is able to support you with the coverage measurements. And that's now in short an overview on the measures and methods in the 26262. And as a final conclusion, before Roland takes over for a small tool presentation, where you have tool support actually for some of these measures, is do not follow the standard word by word. Take your own philosophy and experience and interpret it in a proper way with a proper safety culture, and then you do a good job. That's my take-home message. So Roland, now it's your time.
So you should see my starting screen. Hello from my side, and thank you, Martin, for the introduction and for a lot of tables, a lot of slides with pluses and double pluses. And I think that the last slides you've seen, so there were some pluses about code coverage levels. And now we dive into one solution, how you can measure such code coverage levels. If you've done your assessment of your project and you see, okay, I have to do ACLD to fulfill ACLD, then you end up with measure code coverage in the unit tests with MCDC, and Testwell CDC++ is one of a few code coverage analyzers that are able to measure up to MCDC coverage. Yeah. So there are a lot of code coverage analyzers around, and here are 5 bullet points, and if one of these bullet points fits into your project, it's most likely that you have a good choice when you go with Testwell CDC++ in your project. First of all, we run on embedded targets, and we run on all embedded targets. All means if you have the capability to write out some counter data in different ways that are supported, then you are even able to measure there. It can be done with every compiler and cross-compiler. So this means not only technically, but also from the perspective that you buy a tool that's not limited to use with one compiler. So if you buy Testwell CDC++ and you have different projects for different customers with different compilers, cross compilers, then you can use the Testwell CDC++ license for all of your projects without any additional costs for other compilers. We are compliant to the safety critical standards. In this webinar, we talked about the ISO, but also for DO and for medical stuffs or railway. But in the ISO, it's up to MCDC is also supported from our tool. We do measure code coverage with instrumentation of the code. What this means, this is what I explain you in the next slide, what it means. But it's important, as we do instrumentation, the application gets a little bit bigger than before when we want to measure code coverage, and then we have to take care that even for embedded targets, it's important that we do not hit the limitations of the memory of the devices. Our code coverage analyzer is our home ground is C and C++, and that's, I think it's over 80% of the market in the ISO part for the embedded devices. We also support with add-ons Java and C#. And to understand how we work, we should have a look at 3 steps. What we do, we instrument our code with some of tools of our tool suite. So CDC++ is not a single product, but it's a collection of well-established command line tools mainly, and they work perfect together in a combination to measure code coverage. So we do a first step instrumentation of your source code. Then you see the second box is a white box, the testing itself. A strength of our tool is that we work independent of the way you test. So it can be used in unit tests, but you can also measure code coverage when you do integration testing, whatever test you do. And at the end, in the ideal world, you can combine the results of all the measurements you've done to a single combined report. And the third step, where we need CDC tools as well, is when we do the reporting, and we have different tools to report to XML or to HTML or to text reports. And these 3 process steps, we take a close look at it, and show in one example how it can look like. So if we have software, and then the normal development process is that you have your source code, you compile your source code, you get an executable, then you do your tests, and you get test results. So this is the normal workflow you have when you do not measure code coverage. You simply build an application. For code coverage, by the way, it doesn't matter if your test fails or not. So every test that is executed delivers a part 2 code coverage. So what we measure is, does the test that you have touch all your source code? And to do so, we introduce some probes into your source code with the first process step that we call instrumentation of the code. And let's say we want to measure for decision coverage. Then we instrument a decision in your code. It's if A is lower 10, this is your original source code. This would be modified so that we add some counters. Here is a ternary operator that adds 2 counters, a true counter and a false counter, and whenever your decision evaluates true, we increment the truth counter, and when it evaluates false, we increment the false counter. And with this instrumentation, together with runtime that we deliver with our tool, your application is now able to measure code coverage, to count if the test code touches your source code in that part. So from the first step, we have now an instrumented application, and we have also created an additional file, that's a mon.sym file, where we have a human-readable text file that explains and keeps all the instrumentation we have done to your source code. And we do this on a copy of your source code, so your original source code is not touched. But when you decide to run coverage measurement, then we take a copy of your source code to do these modifications. Then you do with the instrumented application, you do your tests, and automatically this application counts because of the introduced probes. At the end, in some extent, we get a secondary file, a mon.dat file, and then we use in the third step reporting tools to combine these 2 artifacts to a report or 2 different report formats. And the format that most of the customers use are an HTML report that combines the coverage result with your original source code. And next slide, I show you how a report can look like. This is an overview report for a C file where we have decided to instrument instrumentation with multi-condition. That's the highest level that's available for our tool. It's even higher than MCDC. And then we see 2 results. We see the 71% for this file of multi-condition coverage. And we have also 71% of statement coverage for the whole file. And in the table, we see the coverage for each function. So we have here a function lights that was 14 times called, and we have 75% of coverage. So what does 75% of coverage means? You see 75% is the result of 6 out of 8. And we can drill down in this report to a source code view where we easily can see what 75% is. So we have 6 out of 8 probes or counters that were hit. So we have 1, 2, 3, 4, 5, 6, 7, 8 counters, and 2 are 0. And in this source code view, we see the function lights, and it's now easy to detect the missing test cases to achieve 100%. So we have function lights with an argument goal and some decisions here. If goal is off, on, or dimmed, and with the green background color, we easily can see that on and dimmed were part of the test cases, but we never reached this branch, so the goal was never off. So this was never true, this comparison. So we need at least 1 test case where we turn the lights off, with goal off, and then we would have 7 out of 8 coverage, and we would need an additional test case at the end where everything would be green with the first one we have now added, and we still have a hidden branch that's not there. We see you have goal off, on, and dimmed, but what if someone would call the function light with a different argument, let's say with the goal yellow or flicker? So this is 1 additional test case then. So at the end, we need 2 test cases, and then we would achieve 100%. Our tool can be used, integrated in your development environment in IDE. So maybe you know, yeah, Workbench or Visual Studio. So it can be integrated so that you can start a code coverage measurement simply by clicking a menu item. As it is mostly command line based, it's very easy to integrate it in any of your workflow, of your CI/CD workflows. And as mentioned in the first slides, it can be used on almost every target for every compilers. And if you are interested in this tool, the good thing is that we offer a free tool evaluation. So feel free to contact us, and you can, let's say, 2 or 4 weeks try our tool with the full functionality and even with full support. So it's not a community-driven help desk. So we have a support team that's dedicated to this tool, and we can give you support even through your evaluation time, so that you can convince yourself that this is the right tool for your project. And the webinars is one offering we have, but we also offer trainings for customers, or we have seminars with Martin that are 2 days, let's say like this. So if you're interested in that as well, yeah, take a look at our homepage. And I think that's the quick walkthrough for our tool. That should be yeah, the end of the meeting. So maybe Martin, it's up to you to.
Thank you very much. So thank you very much, Roland. As we are actually already out of time, two more questions. 2 questions actually. I want to give a short answer. What is about the assessors? Do they accept such a pragmatic approach I presented here? I can just say from my experience, yes, they do. Even the other way around, they are very happy if they have the feeling that you are starting to think yourself how you fulfill the standard, because all these functional safety standards, also the automotive standard, is actually not really, this is not a receipt, yeah, where you just do it, yeah. Each project has its individual challenges, and you're going to have to find your own solutions, and that's for any assessor the best, actually, if it's really proper assessments. And the second question is about where to document this stuff. It's a lot, as you have seen, a lot of tables and a lot of information, and probably for this webinar challenge, yeah. And yeah, where to document safety, short answer, safety plan, yeah. Document it, put it in a safety plan, define your strategy. And I have really very, very good experience, especially in the automotive industry, because they are not really used to this approach, yeah. But all the assessors I have seen were presented these strategies in a safety plan, detailed document, detailed traceability. There was just silence, yeah, it was just accepted it. So any more questions, I would just ask you to send to either Verifysoft or to me outside of the webinar. And for this webinar, I want to say thank you very much. Maybe Paulina, some last words from your side.
Thank you, Martin. Thank you, Roland, for making this webinar happen. And yeah, you're welcome to join our next webinars and also seminars. You can find them on our website. And yeah, if you have any questions, just let us know. You will find all the contact details on our website, or you can write to Martin. And I think also you will get the recording of this webinar in the next days. So we will keep in touch. Thank you very much.